All right, welcome video people. So we're doing our entry task. So Emma and other people that are missing this, if you look this video, okay, here's the last entry things that warm-ups that you should be able to do. Let's go over the last one before I answer Abby's question. Did you guys get the last one?
Yeah.
Awesome. So what's the answer?
A equals 5n minus 3.
A sub n, the nth term, this is the first term, the second term, the third term, the fourth term, the fifth term, we don't know what it is equal to what?
5n minus 3.
5n minus 3. So we plug in 1, we better get 2. Yep, that works. We plug in 2, we better get 7. We plug in 3, we get 12. Hey, that works. Good job.
Yeah.
How'd you figure that out? Just by trial and error?
Well, the one thing that we did yesterday.
Oh,
But
good.
it's
So
like-
that worked for you?
Yeah, and then you multiply it out.
Very good. So, yeah, because I find it hard. I find it hard. Like that, to come up with that in the very beginning, I don't think I could do it. But what you can do is, what I guess you guys did, is you say, okay, it's always the first term, start which is 2, not 5. It's 2. And looks like we're adding 5 each time, right? That's pretty easy to figure out. Oh, we're adding 5 each time. So it's 2 plus 5. But the first one, we don't want to add 5. So you always put it n minus 1, so that when n is 1, we get 0. When n is 2, we get 1. We start adding 5. So in the very beginning, we don't add 5 because n is 0. But then we keep adding 5. So the nth term, like the third term, when n is 3, 3 minus 1 is 2, so we add 10 to the first one, so it's 12. And then we can multiply that out. 2 plus 5n. 5 times n is 5n. 5 times minus 1 is minus 5. 2 minus 5 is minus 3, so we get 5n minus 3. So yeah, getting this in the very beginning is hard. But if you do it, the first term plus, what are you adding, times n minus 1. This always works for arithmetic sums. Arithmetic sums when you add or subtract a number every time. We're adding 5 every time. That's called it because we're doing arithmetic. We're adding or subtracting a number every time. That doesn't work as well for geometric things, geometric terms where you multiply or divide by a number every time. So anyway, we'll talk about that. So anyway, we're doing chapter 7 here, and that's kind of the gist of doing that. Okay, good. So I have a worksheet with a lot of practice on this stuff. And we talked about sums. Remember this big E tells you if you're summing things. So we talked about if we go sum up from 1 to infinity of 1 over 2 to the n, which is, when n is 1, it's 1/2. When n is 2, it's 1/4. When n is 3, it's 1/9. So all the squares, right? When n is 3, it's 1/8. We just keep multiplying this by 2. Another 2, 1/16. If we keep doing that forever, you guys remember what it is?
Negative 1.
Oh, I know. Yeah, we're going to get to that one. It's good to remember that one. What is it if we keep adding 1/2 plus 1/4 plus 1/8 plus 1/16?
1.
I remember, yes, that's right. Because remember, you can think of it as the square. So if the square's area is 1, first we add 1/2 of the square. And then we do 1/4 of the square. And then we do 1/8 of the square. And then we do 1/16 of the square. And then we do 1/32. And then we do 1/64. And then we do, we keep going, cutting in half, until we get to the whole square. When you get to infinitely many terms, we finish that last stop. Of course, you can't get there. So that's equal to 1. Now, here is a cooler one. And I didn't know this, and I looked this up. It says, what if we have almost the same thing, n equals 1 to infinity of 1 over n squared? Instead of 2 to the n, just switch the n and the 2 around, n to the 2. So that is 1, when n is 1, is 1, plus 2 squared, 1/4, plus 3 squared, 1/9, plus 4 squared, 1/16, plus 1/25, forever. Obviously, it's bigger than 1. does it get to 2? You think? 1/4 is 0.25. 1/3 is 0.33. Keeps getting smaller and smaller. Do you think it gets to 2? Or it could be infinity. Maybe it just keeps getting bigger and bigger and bigger, and if we do enough terms, we can get as big a number as we want. It's hard to tell, right? But since this is getting smaller really fast, turns out it doesn't. Okay, but here's the thing. You're not going to guess the answer because some smart people figured out the answer a long time ago. This is what people did like in the 1700s because they thought this is fun. It is fun. They got the exact answer is pi squared over 6.
That was my next guess.
What the heck? Pi, how does pi squared come out of what why? Pi has to do with circles. And how does this adding up 1/4 and 1/9 and 1/16 what's that have to do with a circle? Doesn't that seem kind of crazy?
Yes.
That we get pi squared, not just even pi, it's pi squared.
Wait a minute.
And that's proven, okay? It's not like the negative 1/12, which is like, wait a minute, what? No, this is actually right. And okay, so what is pi squared over 6? Well, pi is about 3. So 3 squared is about 9. So 9 over 6 is 1.5. But pi squared is a little bigger than that. So it's less than 2, right? It's like 1.6, and someone can figure it out. But it's like 1.6 or something. So yeah, it does not reach 2. It ends up reaching whatever that is, pi squared over 6, about 1.6, a little over 1.5.
One
1.64, and it goes on.
93066848222.
So that's approximately 1.64, goes on forever. So it doesn't quite reach 2. Anyway, it's kind of crazy that we get that result, right? How does pi come in? Kind of fun. Okay, so remember this big E means summing things up, and we write the formula. And okay, here is a cool thing. If you have let me turn this off. If you have an arithmetic sequence, like we just did, where you're adding some number every time. Okay, like right now we are adding a number every time. Then it turns out the sum of an arithmetic sequence of n equal 1 to some number, let's call it I. A lot of times if you want to have the number of terms be n, you count using the little letter I. So from I equals 1 to n, so we say we have 10 terms. And we're summing something up where this is arithmetic. You add 3 every time, you add 5 every time, okay, like we just did. Or subtract 2 every time. It turns out the answer is the average. The average of the first and the last term. Kind of makes sense, right? So if you have n terms, the average is you divide by n, and then you take a1 plus the last term is an. So the first term is a1, last one's whatever n is, if you want 10 of them. You just sum up, and that's the average, right? If you have n, you have 10 of them, you divide by 10, and you average. So let's do an example. Let's do the example we just did. We had I didn't write it up here. What the one we did in the beginning of class, it was 2 plus 7 plus 12 plus 17. We added 5 every time, right? Okay, so let's sum up the first 10 terms of that. If we want to add those first 10 terms up, so we use this formula. So it would be, we'd say 10. So I equals 1 to 10 of, and we had our formula of 5n minus 3. And we don't have to try to do it. We can just use our formula. So it would be 1 over 10. The first one was 2. We got to figure out what that last one is. But we can do that because we have a formula. When n is 10, we just plug it in. So that's 5 times 10 minus 3, which is 50, minus 3, which is 47. So plus 47. That's why you got to get that formula. So now that we can figure out with the formula, we can figure out any term we want, just plug in what it is. So n equals 10, we get 47. So that's 49 divided by 10, which is 4. Wait a minute. The sum. Oh, sorry. We don't want the average. Yikes. Okay, this is, I completely messed it up. The average is this, 1 over n times that. But we have, so that's the average, but we have n terms. So we have 10 terms. We multiply the number of terms we have times the average of each one. That's what I meant to say. Does that make better sense? You find the average terms. This is the average, is inside the parentheses. And if that's the average of them, what's the sum? Well, if you have 10 of them and the average is 5, the sum is 50. So you multiply by n. But notice the n's cancel. So, wait, am I doing this right? Now I'm beginning to doubt myself. This is the average. Divide first and the last. No, that's okay, man. I am completely messing up here. Okay, wait. Let's make sense of this.
What's not making any sense?
If the average, you find the average and you multiply it by. No, that's right. Right. You take the average. On the average, each term is 5. How many terms are there? There's n. So it's n times the average. Yeah, that makes sense, right? So I was right. So the sum is n times how many terms there are times the average of each term. The average value of each term. Well, the average value of each term is you add them all up. Oh. You have to add them all up and divide by the number. But instead of doing that, okay, here's where I was messed up. You just take the first and the last and divide it by 2. That's what I was, not divided by n, you divide it by 2, because we're only adding up first of them. So you take the first one and the last one and divide it by 2, because you're averaging the first and the last, and that's the average of the terms. Yes, that's what I meant to say. I knew something's wrong with my formula. So it's n over 2 times those. So the formula is the number of terms times the average of the first and the last. That makes sense. So it's n over 2 times the first one plus the last one. You don't divide by n terms because we're only adding up 2 of them. The first one and the last one, divided by 2. That's the average of the terms. And then we have n of those. All right, so let's try that formula. See, and we'll check it. Let's check it, make sure it makes sense. Okay, so we have 10. 10 divided by 2 is 5. The first one is 2. The 10th one we figured out was 47. So it sums up to 5 times 49. Let's see, 5 times 50 would be 250, so it's 5 less than that, so 245. So it sums up to 245. Now, I don't want to check that, but let's do it for like 3. Let's check our formula for the first 3 and make sure it works, because we can do that in our heads. So if we add up the first 3, we get 2 plus 7 plus 12, which is 21. 9 plus 12 is 21. Okay, so let's do our formula for the first 3. So we have 3 n over 2, 3 over 2, times the first one is 2, the last one is 12. The third one, A3, is 12, which is 3 halves times 24, which is, oh, it didn't work. I need to get 21. That's 3 times 12. Why is this not working? What's wrong with my formula?
Maybe because it's a Wednesday.
That must be it. The first one is 2, the last one is 12. Wait, 2 plus 12 isn't 24, you guys. 2 plus 12 is 14. 3 halves times 2 plus 12 times 14.
Maybe this has to be
14 divided by 2 is 7, times 3 is 21. Oh, look, it works. I just did my math wrong. It's 21, because 14 divided by 2 is 7. 3 times 7 is 21. So that is work. So so I put a 1 over n. It's supposed to be a 1/2. So that is the formula for the sum It's always n over 2
That's kind of funny.
times the first one plus the last one. All right, anyway, kind of fun. Crazy. Oh, okay, last thing I'll show you, and then I have an assignment you guys can work on, which is very fun. I remember the other day we saw that, as Abby remembered, that the sum of
I feel like you're gonna get lost.
1 plus 2 plus 3 plus 4, if we add up, if we add up 1 plus 2 plus 3 plus 4 forever, 1 plus 2 plus 3 plus 4 forever, it equals negative 112.
You see his teeth?
And
He looks like a bunny rabbit.
okay, you guys remember, right, we watched it, but this is the guy who's talked about it. So we get negative 112. He said it's actually true because they use it in physics to determine stuff about the real world and blah, blah, blah. Anyway, so this guy is another mathematician, and he spends 41 minutes and 43 seconds explaining why that's not true. And that was actually like, they had something like 6 million comments on that video because lots of people watched it because, whoa, how can that be true? And he didn't make that up. These guys didn't make up that result. It's been known a long time, but they presented it as if it's, yep, it's true. And a lot of people are like, no, of course it's not true. You can play some mathematical games to make it look like it's true. So a lot of people got really upset about it, that they're presenting it as if it was the absolute fact, and like this guy. And so he spends a lot of time showing exactly what they did wrong and why what they said isn't really true, and that math isn't so ridiculous, because that's obviously a ridiculous result. Now, it doesn't mean that you can't play some fancy games and get that, because you can. But saying it's true is a whole nother level of what this guy says is misleading, because obviously it's infinity. Anyway, it's kind of interesting. So there's a whole big like scandal about that video and how it's not really true. I find it kind of interesting. I watched a little of it and it's like, okay, I've seen enough. I get that it's not true. Anyway, it's kind of fun. So if you want to watch it, there's all kinds of people arguing. It's not that hard. I mean, it's not like you guys, if you didn't, you certainly could have followed his argument if you pay attention. It's not hard to figure out how to get that result. It's not hard math. All you got to know is how to add and subtract.
2
The
million
question
views.
is, yeah, so almost 3 million people watch this guy's. I think this original one is like a 10 million or something. A lot of people watch
That's a
these things.
lot.
Isn't it amazing sometimes like how many people watch random videos on YouTube? Like,
Yeah.
but then I'm watching it too, so okay, I guess I'm one of the millions of people. But who wants to watch this video? Well, I guess I am.
Like I did have it.
All right, so to practice this stuff, we did a lot. We're just going to do 7.1 and a little bit of 7.2 in this chapter, in chapter 7, and then we're going to move to chapter 8. So those of you who are gone, just look over the workbook for 7.1. We're going to do this worksheet, and then we're going to move on to chapter 8 by the end of this week. So by tomorrow we'll be done with chapter 7. We're not going to do a whole lot of it, and we're going to go on to chapter 8, which is on trigonometry.
Are we gonna have a test on chapter 7?
No.
Okay.
We'll just kind of include some of this stuff maybe in chapter 8 quiz, or I don't know what. I haven't thought about it yet, but this stuff is good to know. What I mainly want you to see, so you never freak out, is because you will see it again. You'll see this big E thing, and people, oh, what's that thing? Oh my God, I hate math. It's like, no, it's not so bad. You go, it's just summing things out, right? You're summing it up n times, like 1 over n squared or something, which means, okay, 1 is 1 plus 1 is half. What is the sum if you do it n times? Or maybe do it infinity times. And sometimes you can do infinity times and get an answer, as we found out. And sometimes you can't. Sometimes it's infinity. And you should know, okay, here's the other major thing you should know. I think this is on some of the tests and stuff. You should know that an arithmetic sequence, arithmetic, is when you're adding or subtracting some number each time. Adding 3 each time, adding 1.5. Adding a fraction can get complicated. Or subtracting. Okay, just doing arithmetic, we're adding each time. And then a geometric, which we haven't done a lot of, that's when you're multiplying or dividing. So multiplying or dividing by the same number each time. So an example, this one would be 1, 3, 5, 7, or 10, 7, 4, 1, -2, dot, 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 right? We're adding 2, subtracting 3. For a geometric, we're like, let's say we multiply by 2. Let's say we start at 3. So we have 3, 6, multiply each one by 2. 12, 24, 48. We're multiplying by 2 each time. That's a geometric. Or let's say we're dividing by 3. Okay, this is tricky. You don't want to go, let's, okay, whatever. So let's say we have something divisible by 3. 33. So we have 33, 11. Okay, then what's the next one? 11 thirds. 11 ninths. That's kind of cheating, but not really. So you just keep dividing by 3. Or multiplying by 1/3, right? Multiply by 1/3. Multiply by 1/3. You just keep putting it. Multiply by 1/3. So 11/27. So I guess it's not bad. If you want to get a decimal, yeah, it's horrible.
Yeah,
By keeping a fraction. So that would be a geometric because we're multiplying or dividing by a number each time. Now there's ones that's neither of those. There's like exponential or something. There's ones that aren't either of these, and that's okay. But these are two very common ones. Arithmetic series and geometric series. All right, so I have this worksheet for those of you who are gone. We'll have to get it to you. And then we're moving on to chapter 8. So thanks for listening, you guys. Keep in touch with me to figure out where you are and how you can get things.